To be sure, the heart is capable of beating by itself with nothing more than a good blood supply. If this weren't possible, you could never have a heart transplant, since with transplants of any kind, including the heart, you don't ever connect the nerves. Instead, without nerves, the denervated, the transplanted heart still beats at about 90 to 100 BPM by itself. Let's see how the normal heart operates. In the medulla oblongata or lower brainstem, there are nuclei, collections of nerve cell bodies, that regulate the heart rate. These contain the nerve cells for have two major branches, the sympathetic and the autonomic nervous system. This system is parasympathetic. The sympathetic nervous system is the fight or flight system of the heart, which causes it to beat more rapidly, just as you would notice if you were suddenly frightened by something. The parasympathetic nervous system has the opposite effect, slowing the heart rate. There are nerves for both of these branches that attach to the heart to influence the heart rate. You may have heard of the vagus nerve. It is the 10th cranial nerve and the main supplier of parasympathetic nervous system activity to the heart. When it influences the heart to slow it down, this is called the vagal brake, acting on the heart. The process isn't entirely automatic because you can purposely think of a scary thing and cause your heart to race. Your thoughts come from the cortex and travel through the hypothalamus to the medulla oblongata. This will activate the sympathetic or parasympathetic branches to affect your heart rate and blood pressure. But it can happen without thinking as well, because you can sense danger from your body without full conscious thought. Such a thing will also influence the brainstem and affect your heart rate and blood pressure. The brainstem's two main nuclei are the nucleus tractus solitarius, NTS, or solitary nucleus, which is influenced by chemical receptors, as well as ones called baroreceptors that monitor your blood pressure. When this gets activated, it turns off the rostral ventrolateral medulla's nucleus to put out sympathetic nervous activity. The parasympathetic neurons in the dorsal vagal nucleus and the nucleus ambiguus, also in the medulla, get activated by the NTS. They trigger the activity of the 10th cranial nerve, slowing the heart rate significantly. The heart always has some vagal brake from this nerve all the time, so that the actual normal heart rate is less than the denervated set point of about 100 beats per minute. The hypothalamus also has a role in all this. If you are stressed from exercise or excessive heat, it is for occur if you are sick or anxious. For example, this will stress the sympathetic nervous system in order to speed the heart rate. It will also, there are a couple of terms you should know concerning the heart and its innervation, including chronotropy. This is related to the heart rate itself and essentially means anything that can change it. A positive chronotropic agent will speed up the heart, while a negative chronotropic, the agent will slow it down. Inotropy. This refers to the strength or force of the contraction. Some drugs will increase the heart's inotropy and others will decrease it. Dromotropy. This refers to the velocity of electricity through the cardiac conduction system. Sympathetic influence on the heart will increase the heart's dromotropy, while parasympathetic influence will decrease it. Various medications can positively and negatively affect the heart's dromotropy. There is regular innervation of the heart that has nothing to do with the autonomic nervous system. This comes from the phrenic nerve, which emerges from the neck at the cervical roots 3, 4 and 5 through the 5th cervical vertebral area. This provides sensory and motor innervation to the pericardium and diaphragm. It can often cause chest pain that isn't coming from the heart itself, but instead is a referred pain that only feels like it. To sum things up, you now know a lot more about the heart than perhaps you've ever learned before. It is a vital organ necessary for our survival. Its main job is to pump blood to the lungs for oxygenation, and then pump the oxygenated blood to the rest of the body. It has 2 atrial chambers that receive blood and 2 ventricular chambers that eject blood. The heart's electrical system or conduction system is how the heart can regulate the contractions in a specific way. There is the main pacemaker of the heart called the sinoatrial node or SA node. The signal it creates gets sent to all parts of the heart in a specific pattern. As each heart muscle fiber or cardiomyocyte gets activated, the heart will contract in a unified fashion to allow it to act as a functional syncytium, which squeezes blood out like you'd squeeze a tube of toothpaste.